Greetings, YouTube. Beautiful Mind here. So this will serve as the lecture for week 4 Friday for support for college algebra. No major announcements other than exam 2 has been up most of the week since about Tuesday or so. It's due Saturday by 11:59 p.m. And be sure to do the participation and honesty quiz that is available on Moodle. Everybody should have full access. If you don't have full access, reach out. We can be sure to get you set up there. And this is actually just a short lecture. I really just want to be available during class time for questions and support. So let's take a look at this. So we're going to go ahead and do the last section for chapter 8. This is going to be section 8.5, solving system of linear inequalities. Okay. So the objectives here are to solve a system of linear inequalities graphically. Let me see, can we do this algebraically? I guess I thought that, I don't know, but let's just look at it. To solve a system of linear inequalities graphically, graph each inequality on the same axis. The solution to the system of linear inequalities is a set of points whose coordinates satisfy all inequalities in the system. Let's just see this in action. All right, so it says determine the solution to the following system of inequalities. Let me see. Okay, so if we're going to do this graphically, I'll do this one manually. I'll do this one by hand. Let me get a copy of it first. Delete. Yeah, I can't see this. All right, that. We don't need this. Let's go here. Okay. Oh. Shoot. I didn't think about that. Okay. And this. All right. So we're asked to determine the solution to the system of inequalities. So we're going to basically just graph these two. One of them, I usually like to start by getting a copy, just writing them. So if the original is x plus 2y is less than or equal to 6, so I'm going to solve for y in both of these, all right? Get the y by itself. So if we subtract x from both sides, we'll get 2y is less than or equal to negative x plus 6. Divide both sides by 2, and y is less than or equal to negative 1/2 x plus 3. And then the other one was y is strictly greater than 2x minus 4, right? So then all we're going to do is graph each of these inequalities on the same axes, and then pretty much choose test points. Like that's how I'll go about it. I guess I can't undo it. Okay, that's fine. Uh-oh. There it is. Okay. There we go. Okay. So, let's see. Let's see, negative 4 and 3. So let's just put the origin about here. We'll go 1, 2, 3, 4, 5, 6, 7. I guess it should be more than enough. Let's copy, paste. Go this way. 1, 2, 3, 4, 5, 6. Let's just go with this for now. Positive x goes in this direction. Positive y goes in this direction. Okay. So let's do this one in blue. It's just the first color that came to mind. All right. So we to graph something like this, we graph it just like if it was a regular line. Y equals mx plus b. So the b was like y-intercept is 3. Oh, let me label my axes. So this is 1, 2, 3, 4, 5, 6, 7. This is the origin. 1, 2, 3, 4, 5, 6. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. 1, 2, 3, 4, 5, and 6. Okay. I'm going to do one thing really quickly. Copy, paste. I just wanted to have a blank graph ready to go. So I went on and copied that slide. So I can use it in the future if I need to. At least for this lecture. Okay. So if we're going to graph the blue part, first it says the y-intercept is 3. So that's where it crosses the y-axis. Then the slope is down 1 and right 2. So if we go down 1 and right 2, that gives us a second point. I'm going to do that a few more times. Here, here, and here. I'm going to go the other direction. Up 1 and left 2. Okay. So then if we draw this across the whole axis, that looks good. Okay. Let's see. Because it's equal to, so the line can be solid, that's fine. And we'll do the next one. I guess I don't really want to do, we'll do it like this color. This color's fine with me. So that one says the y-intercept is negative 4. And then the slope is positive 2. So we go up 2 and right 1, put a point. Up 2, right 1. Up 2, right 1. Up 2, right 1. Up 2, right 1. And let's go down 2, left 1. Now notice that this one, because there's no bar under the inequality, instead of, so let's see, here's our line, but, nope, hang on. Let's try that again. Yeah, that's better. Okay. So instead of being a solid line, because this is strictly greater than, y is strictly greater than, this needs to be a dashed line. So we're going to transform it to a dashed line. Let's see how this goes. Okay. So it's a broken line. That means it can't be equal to that line. So then to shade the proper region for the blue part, let's do a blue in this one. It says, okay, if y is, we can choose a test point, right? If we're focused on the blue line, say we choose the origin 0, 0. If we choose the origin, does it make it true or does it make it false when x is 0 and y is 0? So if x is 0 and y is 0, so we're going to have 0 is less than 3. That's true, right? 0 is less than or equal to 3. That's true. So we would shade that region. Let me see if I get this polygon to activate. So I want something like this, 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 Ugh, messed up. That's okay. Nope, that's not the shape that I want. I want this. Why won't it do it? All right. It did that one. Anyway, whatever. Okay, so what I'm gonna do is go like this. How many points? I need 1, 2, 3, 4, 5. Let me try that one more time. Let's see if I can get 5 turns. 1, 2, 3, 4, 5. Oh, almost. 1, 2, 3, 4, 5. Cool, that's what I need. Okay. So then I can move this one here. This one goes here. This one goes here. This one goes here. Oh, I guess I didn't need that many. 1, 2, 3, 4. Okay, I only needed 4. But anyway, this is still the shape that I need, so I can use it. Then we're gonna go style. We're gonna fill it with blue. All right. Okay. So, because the origin made it true, we shaded everything below that line. So everything below this line will make, all the shaded region will make that blue line true. So then for the, so let's see, 1, 1, 2, let me see, 1, 2, 3, 4. Okay. So then for the pink line, we're going to choose the same test point, 0, 0, right? So when x is 0 and y is 0, does it make it true or does it make it false? So let's see, when x is 0 and y is 0 bigger than -4? That's true, right? So that means that we would shade the region that contains the origin. So we're going to shade above the pink line. Let me see. 1, 2, 3, 4. Okay, let me see if I can get that thing to activate again. 1, 2, 3, 4. Okay, that's what I need. All right. So this first one can go here. The second one can go here. This one goes here. And this one goes there. Awesome. That's it. And then style. And we're going to fill it with this one. All right. So, undo. So these are the, so this is, we shaded above the pink line, right? So then if we want the solution, let me think about this. It's going to be all of this region, but how would we capture that? So the solution should be where they overlap, right? What's common to both is going to be the purple part. I feel like I'm drawing a blank. Let me think. Give me a moment. Let's see the solution. Let's see what it looks like. We did that, and we did that. Let me see. I think we got the same image. Okay. Give me just a moment. All right. Sorry about that. Okay. So let's compare our result to what they have. So it says Now on the same axis, graph the inequality. Note that the boundary is dashed. The solution set is a set of points that are common to both inequalities. The part of the graph that contains both shadings, the purple color, the dashed line is not part of the solution. However, the solid part is. Yeah, so it's basically just the purple part. Let me see something. The order pairs of each of the solutions. Let me see something. I mean, that's fine. We could choose any point in the shaded region, substitute both inequalities. We will choose. Okay, so yeah. So I guess my hesitation was coming in. I was thinking like, okay, because I was tempted to write like an interval or something like that for the solution set, but then I was like, well, I don't know. Long story short, I was just kind of spacing out a little bit. But yeah, so the solution is just going to be the purple, which is what we got. I don't really know I can't think of anything else to say there. Now to check, what we could do is choose a few test points, right? And make sure that they all work, right? So for instance, let's go back to our graph, just to kind of check. Okay. So if we're saying that this is the solution, I want to kind of move this over a little bit. Let's go here. Okay, well, yeah, we're essentially done after this. It's not very long, like that's just how this one. Okay. So for instance, we're saying that anything in the purple region is going to be a solution. So we can choose any point in the purple. I'm just going to choose a point at random. Let's choose like this point here, right? So that point is what? Negative, shoot. I forgot, I took it off the graph. This, like that. Let me line it back up with the grid. Then they're distorting it, it's throwing it off. All right, I'll just have to eyeball it. So I'm gonna go like this. Come on. I'm gonna turn this off. Okay, so let's just choose a point at random. Let's go here. All right, so I intended this to be the point -5, 2, right? -5, 2. So what we're saying is that -5, 2 should work in both equations, all right? So then -5 plus 10 is indeed 6. Okay, and then -10 x is -5. Let me think about it. What is that? That's a -10. That's a -14. That one doesn't work. But it should. Oh, it's less than. Okay, yeah. Okay, let's back up. So -5, 2, right? So here. -5 plus 4 is -1. -1 is less than or equal to 6. That checks out. That's going to be a -10 minus 4 is -14. 2 is indeed bigger than -14, right? Something that, and if you choose anything outside the purple, any point outside the purple, it's not going to work in both equations, all right? So to solve this system, we just graphed it, and basically we're just looking at the region where they overlapped, okay? I don't know why they gave me such a hard time. We typically don't talk about this. I didn't really mind talking about it, though. I thought it would be interesting just to kind of change it up. But we've essentially already discussed everything that we needed to for this week. I just wanted to kind of throw this on there. There it is. Okay. So yeah, we got the same thing. I can't think of anything else. So yeah, again, I just wanted to be available. Oh, we got another one. Okay, let's go ahead and do it. We'll do this one by hand as well. Determine the solution to the system. Well, it's okay. I think what they have is fine. So this one asks, determine the solution to the system. We have y is strictly less than 2 and x is strictly greater than 3. So if we were to graph this line y equals 2, that means no matter what x we choose, y is always 2. So it would be a horizontal line through 2, but then we got to go back and make it dash because there's no bar. So you see this horizontal line through 2, but it's a dash line because it's strictly less than 2, right? So then to shade the proper region, we consider the origin. If y is 0, does that make it true or does it make it false? That makes it true, so we would shade below this line in red. Okay. For x is strictly greater than -3, no matter what y value we choose, x is always -3, so you see it here. But then it needs to be a dash line because x is strictly bigger than, is not equal to -3, so that line is dashed. Then we got to decide, do we shade the left of that line or the right? So we choose the origin. So when x is 0, does it make it true or does it make it false? That makes it true, so we shade to the right of that line. So to the bottom of the first line and to the right of the second line, and then they overlap in this purple region here. So anything that's purple is going to be true. Anything outside the purple will be false in this case. Okay, let's see. Is there another example? There is another example. Let's do this one. Oh, even though we can see it. I'm being lazy. Okay. So, I mean, so notice this one, right? The first one, the y-intercept is 1. You see it here. The slope is a -1/2, so we went down 1 and right 2. So they graphed the line. Notice the line is solid because it is equal bar, so it's a solid line. Then we ask ourselves, okay, do we shade above or below the line? So we test the origin. If we plug in the origin, does it make it true or does it make it false? Is 0 bigger than 1? No. So that means we would shade the other side. We're going to shade above the line. This one, if we solve for y, subtract and divide, we still get our -1/2. And the y-intercept is -1. So the slope is still down 1 and right 2. And then if you choose your test point, you're still going to see that we shade this region over here. So notice that the lines are parallel, they never cross, and we shade opposite ends. Therefore, there are no points that satisfy both inequalities. So the system has no solution. Okay. So I know I kind of went a little quick on those last few examples, but I'm available. Like if you have questions or if you want me to work any kind of, like I don't mind. Like I kind of enjoy doing the dedicated YouTube videos, but yeah, I'm just here to answer questions really. Oh, that's driving me nuts. Okay. So I guess with that, we'll end the session here. It wasn't really much that we needed to do today. And this, this isn't really, it's just there, Again, I'm just here. I'm here to kind of answer questions and for support. And so on that notion, we're going to end this session here. And from one beautiful mind to another, enjoy the rest of your day. Peace.